Alright, let me explain the two parts that are still missing from the project, i.e. the Arduino or ESP32 programming, and then the website using PHP. When you first start your Arduino IDE, you have to install some support for your ESP32, which you do here. You add a board manager URL and then you say OK, and that enables you to find the board that you actually are using. My board is an ESP32 dev module, so I will select that and it will make some changes down here at the right hand corner. It's going to show you what is the setup that I'm using, and when it's done I would go and make sure that I can see my ESP32 here on the COM ports, and then I would open my code, and the code looks like this. First of all, you have to install some libraries like HTTP client library and the Adafruit BMP280 library, the Liquid Crystal I2C library, and the TinyGPS++ library, and that will bring you the software serial as well. That will not be covered in this tutorial, and it's not really a tutorial even, I'm just explaining how this thing works. So let's go to the code. First you have your wireless LAN settings, then you have your target server settings, you have your libraries for your parts. This is for the BMP280, the Liquid Crystal, and the software serial, and the TinyGPS. And this is where you create a GPS object. And here you create a software serial object. Here you start the LCD display. Here you connect to the wireless LAN. And here you start displaying stuff on the screen. LCD print is always printing on the screen. This is what you see when the device boots, with wireless LAN connecting, and then connected, and the local IP is shown here. Then it says this, and if you cannot find your BMP280, it will tell you this, and this is where you give the address of your BMP device. Settings we don't care about. Put in the GPS. This is where it will take 5 seconds to get your GPS library going, the GPS device going, and after that we have the loop. In Arduino and ESP32 you only have two mandatory parts. The first is the setup function, and the second is the loop function. The setup function is run once, and the loop function will run as long as you give power to your ESP32. So this is where we just go and get the latitude, the longitude, the altitude if we can get it, and the number of satellites. Then we go to a function called getTempPressure, which will give you the atmospheric data. Then you write everything on the LCD with the function, and then you have a function called updateWeb, and then we wait for 10 seconds. So the interesting part actually is the updateWeb, and this is where we will be creating an HTTP client. We will connect to the server name I showed you at the very top of the file, and then we have just one string. It's a request data, has the latitude and a comma and a longitude and a comma and the temperature, pressure, altitude, and the number of satellites. And then this one here actually does the HTTP post, which sends the data. And if you were looking at this on the serial monitor, you could see the number 200 here whenever it has a successful sending operation. So it's very, very simple. All you have to do is to create a client and give it the address where you want the thing to post, and then you can see it sending the data. And this program will just run over and over and over again until it runs out of time. So let's go and see what happens in here. This is the file where the stuff goes to. If we go to the very end of the file, we can see that at 09:43 today our device stopped working, but here we have data that actually works. So you can see there's a timestamp, date, first the date and then the time, and then you have the latitude and the longitude and the temperature, the air pressure, the altitude from the ground if you can get it, and then the number 3 means the number of satellites. And this is what we see if we go to the map interface. We can see that the device is currently here in this building, which happens to be the Haaga-Helia Pasila campus. I'm here on the 6th floor, but because of the device being unable to see more than 3 satellites, it doesn't give me the altitude information. But if I went outdoors and stood here for a minute or two, it would then tell me how high I am from the sea level. Now, how does this actually work? It works so that in the cPanel file manager, I have a bunch of files. This index.php is the file that shows me the map interface, but the interesting part is this one, iotwrite.php. Let me show you how it works. This is very, very simple. I mean, everything that we have seen today is actually very simple. This is what happens. It gets the input from the PHP server. So when I said that I have an address where my device is sending the information, this file is where it is pointed at. And it will then create a my year, my hour, and it will then start writing data into this file in here, which you just saw. It tries to open it to append, and if it cannot open it, it will simply die, which is what happens. And then it will just write my year with a space in it, like you can see in here. Yep. The date and the time, and then it will take whatever it has in the post. This is what it gets from the input, and it just writes all of that data in here, and it looks like this. This is what my device is sending, and it will then just write a line change and close it. And it also does a backup into the data IoT logs just in case something goes wrong. And when you go back into the file manager, you can see that the index file, if I open this one for you, you can see that it is doing some styles in my styles, which it shouldn't be doing. But then it uses the file load.php to extract the data, and then it uses that data which it found in the text file to add it on the top of the map. Everything is here, and I definitely don't claim that I would be able to write all of this. This was actually written by a student who spent some time figuring it out, but now it works, and we can use it whenever we want to use these boxes. So you do need a couple of files in here. The explode data is needed, extract data is needed, but this is where the data goes, and this is where the data shows. And that's all there's to it. Your final layout looks like this. And if you had more boxes, we can actually go into a different address, IoT00, and you'll, this is where our boxes were when they died, when we had the International IT Seminar in Helsinki in April. We had 10 boxes, and I have the locations of the 5 final boxes, or the final locations of 5 boxes are still recorded on this system. So that's how you make a GPS box. If you have any questions, I'll be happy to answer them at heikki.hietala@haaga-helia.fi, haaga-helia.fi, or you can find the hh3dlab.fi and ask me any questions out there.